Um, I'd like to show how to design simple span beam. You need to go to design module. You can see several different types of a beam module here. For this example, I choose floor beam module. Click that one, and then left side mouse button, click and hold it, and go to any direction you want. Then lift up where you want, and the program show the length and the beam's name. You can adjust length here. You can change the name here. Then you need to check the umbrella length kind of things. But for this example, I like to make it simple as possible. So we need to just use default setting. So uh, the adjust factors and some other design criteria, we just use default setting. The next we need to choose the material of the beam. You can see here there are several different types of the material: solid stone, glue beam, structural composite, and I-joist steel here. For this example, I like to choose only one material. You can choose the several different types of the material. Okay, for this case here, we open up, and then it showed all information. So you can see many different types of the species, and there was a grade here. I like choose number 1. Then different size of the member. I like to have a 4 by 8. Okay, so we finished it. The size and there was types of material. Then we need to apply the loading for this beam. Go to the loading condition. Let's choose the point load for this case, only one, and moving around right this way. Or on the right hand side, you can see the location here. You can type in the distance. You can moving around like the 8 right this way. Now you can enter the size of the dead load. We have a 300. Live may be about 600. Of course, you can choose different types of the live load here. Then you need to go to calculation and calculate. So it shows the numerical result and left hand side that is based on the size and the species, also loading combination. That's why there are several the calculations show up on the one place here. So that the 4 by 8 that the live failed, and then so that for this case here we need a structural composite. It's fine. So we have to pick it up this one here, 4 by 8, like this way. So this is a simple span beam design. And then next, let's show multi-span. For convenience, we just increase the length. So this one is 15, but I like to show this one 25, right this way. So then I like to add more support to make multi-span. For this example, I like to show 3 more hinges. Of course, you can add as many hinges as you want. So click this one and show up here, and bring up the more hinge here. Click this one, another hinge. Click this one, another hinge here. So where do you want, you can put it. Of course, this if you numerically change it, maybe this one is a 16 like this way, you can do the way. So precise setting, you may use the numerical setting, not the graphics. Then of course now you some circumstance you need to change the support condition. Like this one, if you click this one here, it shows 25 and all the information about these hinges here. Then it shows that what kind of support, the hinge support. Then if you click this one here, it shows the different types. So for that case, if you choose fixed support, and then you can choose also the free support like this way. But yeah, some cases is going further. Anyway, then choose the hinge support. Back to same one. Go to 25 here. Make sure correct one. There also you can add more point node here. So you can put a point node as you want. Maybe this one is 600. Another point node. You can moving around 600. Another 900. Done. Then for this example, I'd like to show the distributed loading here. So click this one here. It showed all information here. And for distributed loading case, we have two different types. One is PLF, the pound linear per foot, and the other one is pound for linear square feet. So first I like to choose a pound per square feet. And for this beam is a floor beam, so I like to change this on 40 here. And then 3-bit width, I like to have 4 here, and then I like to have 2 here. And then also I like to adjust the area, and then maybe 12 here. So this way. And the next is I like to put another distributed loading here, so that they're starting from maybe 4 here. And for this case, I like to apply pound per linear foot. And then I like to start this one is 100 maybe, and then apply it. So like this way. Then is now we click the calculation. So it showed all the information here. And then we show the detailed calculation as before. Then also you need to go to design chart. There is a graphical information. It takes time to generate that information. Then so you can see that this one is a moment and the shear and the display deflection kind of things, and then also some other beam information. So checkmarks is passed like this way. So actually on this design, all members fine. But anyway, now is we like to have more information. So for sometimes we like choose choose different types of loading, like for example different types of member, so that like for example this glue and beam here, and they show up the grade and those thickness. Maybe I like to choose the 9 inches. And then also I like to know the steel members, and in that case, most of the case we like to use tube steel for this case here. So that go to click this button here. It bring up all the information of steel member, and then I like to choose that rectangular shape, so that scroll down and then the member you want, and then OK button. So and click the button. So it shows up all the informations here, same as before. Yes. Decision chart, same as one, similar idea. It takes a little bit of time to generate the graphics, many graphics, yeah. So that's why, yeah. Okay.